Hello, my name is Angelina. I'm a researcher with the Atmospheric Chemistry group at the University of Bristol, and welcome to our lab tour. Our group does atmospheric measurements and modeling.
But since this is a lab tour, I will mostly show off our instrumentation. You probably know how computers look like. As you can see, we have a lot of boxes. They're not necessarily black boxes. They're mostly gray boxes, some beige ones, and at least one pretty blue one. This is not really how people imagine laboratories to look like, because we measure the concentration of stuff in air. You cannot really see what the machines are doing by eye. So I'll try to hopefully explain a little bit of what happens in the boxes and what we are doing with it.
There's predominantly two different types of instrumentation that we use. They're mostly Gaschromatographs or light-based instruments.
Gaschromatographs are basically just very fancy ovens. Inside the gas chromatograph, you have a long, thin piece of tubing. So it has maybe the inner diameter is a little bit bigger than a hair. And your gases travel through that. And molecules that have a very low boiling point will travel through it very fast. And things that have that are less volatile, that have a higher boiling point, will travel through it either very slowly, or maybe you have to heat up the oven before they start traveling through at all. But it does mean that you can separate different compounds, mostly according to their boiling point, but it's also some compounds are a bit sticky, so they stick to the side of the column. And they can travel through a little bit slower as well than compounds that just ignore the sides of the column. The most volatile compound we measure on our instruments has a boiling point of minus 130 degrees Celsius. And the least volatile compound we measure on the same instrument has a boiling point of plus 110 degrees Celsius. The other type of instruments that we have are light-based. Basically, all molecules absorb certain wavelengths of air. How much of the light that they absorb depends on the concentration that you have of that molecule in your sample. You can think of it a bit of like if you would be diluting paint. So if you only take a tiny amount of paint and you dilute it in a lot of water, you will get a very transparent solution. And if you look at it through the light, most of the light will still shine through it. But if you take a lot more paint in the same volume of water, you will get much less light going through it. And the instruments we have are very similar to that. Our instruments are laser-based, so we shine a laser of a specific wavelength through a sample, and then the compound we want to measure will absorb a little bit of that light, and how much it absorbs depends on the concentration of that compound within our sample. Some of the equipment that we have, like this optical laser instrument here, is bought directly from companies. This instrument can measure, typically they can measure about 2 to 3 different compounds at once. We use this one here specifically to measure carbon dioxide and methane concentration, and something like this costs about £80,000. It measures concentrations in the parts per billion range, so it can detect about 1 molecule of carbon dioxide in 1 billion of molecules of air. That is about the equivalent of a drop of water in a swimming pool. For the other instruments, we buy some parts, but we have to build the rest of them ourselves. And that usually makes them much more expensive. For example, these instruments here, there are only about 30 of them in the whole world, and we have 5 of them. To make one of those, it will cost you about £300,000. And it doesn't just measure 1 or 2 compounds, but it measures 50 compounds at once. And it does also measure to much, much lower concentrations. So while the optical instrument before was about, 1 drop in a swimming pool that you could measure, this one here is more of you can measure 1 drop in 10,000 swimming pools. Because we built some of the instruments ourselves, our lab has a lot more tools than probably most labs have. And we also have a whole room dedicated just for electronic parts, tubing, fittings, things you need to build instrumentation. Most of our instruments are not in this lab, though. Most of the instruments are deployed at measurement sites. We have stations, sites all around the UK. There's some instruments in Ireland, and there's one that is in Barbados. Of course, we sometimes have to go and fix them or do maintenance, and that is usually, well, sometimes it's quite fun, sometimes it's a bit frustrating. Unfortunately, the one in Barbados, of course, never fails when I would be the one who would have to repair it. It's very sad. So we have to travel around a lot to fix the instruments. Our sites in the UK are mostly located at telecommunication towers, broadcasting towers, because we quite like to measure the air not right at ground level, but a little bit higher up. That is mostly because at ground level you have a lot of emissions. You could have carbon dioxide from cars, or you could have methane from cows. And if they walk just, right past your instruments, then that is not necessarily very representative of what are the UK CO2 emissions. That is just like, oh, I've just measured this car. So we like to measure from a bit higher up to get a bit of better mixed air. And this is why we are locating our instruments at these telecommunication towers. The highest inlet that we have is up at 185 meters.
I hope you enjoyed the tour of our lab, and I hope you have a little bit of a better idea of what I do here at the University of Bristol, and hopefully we will see you soon as students.